Okay, hello everybody. We're going to talk about section 8.2 on operations with radical expressions, and some of our goals in this particular section is to deal with identifying if a radical term is rational or irrational. Secondly, identifying whether a radical term is in its simplest form. We should be able to simplify a single radical expression. We should be able to add and subtract radical expressions. Now, if you recall from the last section, one of the things that we were able to do was that we were able to find perfect roots. That is, for example, if we took a square root of a perfect square number, for example, if I were to tell you that I had the perfect square of 121y to the fourth, you would know that that was reducible as the square root of 121 and the square root of y to the fourth, which becomes 11y squared. So we were okay with the idea of being able to reduce perfect root numbers, right? Cube root, a good example of a perfect cube root would be 27, right? 27x cubed. And we know that this expression would reduce as 3x. So we're okay with perfect radicals, but what if it's not? What if it's not a perfect radical? Well, sometimes we have numbers like the square root of 2. We have numbers like the cube root of 7, right? These are irrational numbers. They are not reducible as perfect squares or perfect cubes. So we would have to leave these in that particular form. Now, sometimes we do get expressions that we can reduce that are both that contain factors that are perfect squares or perfect cubes or something else like that. And our job is to rewrite the expression in such a way that we reduce it. And our rules, our main tools are these rules. The multiplication rule, which says that the nth root of the product a times b is the same as the nth root of a times the nth root of b. And a division rule, which says the nth root of a over b is the same as the nth root of a over the nth root of b. So what could we do? Well, let's talk about this square root of 18. 18 is not a perfect square, but 18 does contain a perfect square factor, and that is 9, right? 18 is the same thing as 9 times 2. Now, that's not to say that 18 isn't also 6 times 3, right? Which is okay, but neither of those two factors are perfect squares. So we use our multiplication rule, treat this as the square root of 9 times the square root of 2. Square root of 2, that would be a better square root of 2 if I could write it nicely. And that becomes 3 times the square root of 2. And this is considered simplified form of this expression. So when we're simplifying radical expressions, what we're looking for are factors, or when we have square roots or cube roots or something like that, that have no more perfect cube or perfect square or perfect root factors. Those are factored out. So let's talk about another one here. Let's try about the cube root of 250. Well, what do we know about that? Are there any perfect cube factors of 250? That's right. If you divide this up and treat this as the cube root of 125 times 2, right, 250, we can divide this up then as the cube root of 125, which we know reduces, and the cube root of 2, which we know does not. There is no number, no whole number that when multiplied by itself 3 times gives us 2. So we take our cube root of 125 and reduce that as 5 and say that our reduced expression, our simplified expression, is 5 times the cube root of 2, and we would leave it in that form. Okay, how about this one? The fourth root of 32 over 81. Well, what fourth power numbers do we know? We know that 2 to the fourth would be 16, and 16 is a factor of 32, so that's actually useful. And 81, let's see, 3 to the fourth, yes, that's 81 as well. So What could we say? Well, in this case, in fact, if we use our division rule up here, we can treat this as the fourth root of 16 times 2 divided by the fourth root of 81. And reducing this still further, right, if we take the fourth root of 16, we know we're going to get 2, and we're going to take the fourth root of 2. That is not a nice perfect even root here. And the fourth root of 81. And so when we reduce this expression, we should get something that looks a little bit like this. The fourth root of 16, which is 2, times the fourth root of 2, all divided by the fourth root of 81, and that's 3. And that would be our simplified expression here. Okay, more to come in the next video.